welcome to my talk on well, basically strategies for incrementally taking your monolith and breaking it apart into a set of services. So what I'm going to talk about is, just an incremental approach. So no big bang, just do it one service at a time. Before I get into that, a little bit about me. Been developing software for quite a while. Actually, I think my first paid job was 1982. Over the years, worked on Lisp systems, wrote the book Pojos in Action, created the original Cloud Foundry. And then for the past 5 or 6 years, I've been pretty much focused on the microservice architecture. So travel the world doing consulting and training, help clients adopt the microservice architecture successfully. Also have a startup called Eventuate we're building a platform to simplify the development of business applications, which are basically transactional in nature that use microservices. My book, Microservices Patterns, came out back in November, and you can get it with a 40% discount with that code, which is like CTW, Oracle Code 119. And I will show that again at the end. And I also have microservices.io, collection of resources for learning about using the microservice architecture effectively. And we recently added an assessment tool so you can self-assess your microservice architecture. So that's me. I basically just do microservices. So I'm going to start off with briefly providing the justification for using microservices just to set the context. And then after that, I'm just going to dive into the process of breaking apart a monolith, which is a long, painful process, which I suspect many of you are actually dealing with today. So anyway, so why microservices? And I think this slide really sums up the primary motivation for microservices. Number one, software is eating the world. Every company needs to become a technology company. Software is central to their products and to their services. And you combine that with the fact that sort of the marketplace within which companies operate in many, many industries is becoming much more volatile, uncertain. New competitors emerge out of nowhere. And what that actually means is businesses need to innovate at a much faster pace in order to deliver new products and services and remain competitive. And what that means for us as IT people is we need to deliver software much more rapidly, frequently, and reliably than we have done it before. So in particular, we need to, instead of periodic large releases that occur, say, once a month, the state of the art is deploying into production many times a day. Each developer commits once to trunk, and that change gets pushed into production. So that's sort of kind of the context within which IT or us developers are operating. Now, the monolithic architecture is not an anti-pattern. In some situations, it can be quite effective. You can deliver software rapidly, frequently, and reliably. The challenge that you run into is as your application gets larger and larger over time, all of the desirable architectural quality attributes like maintainability, testability, deployability tend to just decline over time. It gets harder and harder to deliver software. And this is a problem because sort of the marketplace is saying deliver faster and faster. So we've sort of got this divergence, which really can represent an existential threat to the business. And this is not 100% guaranteed with the monolithic architecture, but it's extremely common. So that's why microservices. And just briefly define it, right? So it's an architectural style that structures an application as a set of services. And I actually, as I mentioned before I got started, I don't really like the term microservice because it implies tiny. Right? Like someone made a comment like next year it's going to be picoservices. And you just sort of have to give up that notion and just think in terms of services. And the goal is to have services that are highly maintainable, testable, loosely coupled, independently deployable. And they're also owned by a small team. And in fact, a good starting point is just to have one service per team. So not super fine-grained architectures like one service per developer, but coarse-grained architectures with one service per team until that becomes a problem. And it's useful to introduce more services. And the reason you do this is the microservice architecture gives you the testability and the deployability you need to do lean-style product development and DevOps-style delivery, which includes continuous deployment and continuous delivery. It also has the sort of the modularity that you need for sustainably developing very long-lived applications where you want to periodically upgrade the technology stack. With microservice architecture, you can do that one service at a time. And then also it gives you the modularity and the loose coupling that's necessary to support the organization of your engineering department into a set of loosely coupled, high-performance cross-functional teams. So that's sort of the whole goal behind microservices. It's really around rapid, frequent, and reliable delivery of long-lived applications. So that's super brief introduction. So most organizations who want to adopt microservices actually already have a monolith, and usually it's a very large, very complex system, and it's usually very mission critical. So how do you kind of do this refactoring? And also, when do you start? And I think I'm sort of semi-joking here, right? But you want to be extremely cautious when adopting the microservice architecture. In fact, you should do everything within your power to avoid using microservices and just leverage the monolithic architecture because it's a lot simpler. So it's not an anti-pattern. Try and use the monolithic architecture. So if you want to speed up software delivery, just optimize your development process, automate your deployment pipeline, modularize it, make sure it's more loosely coupled. And then if your technology stack is obsolete, don't automatically assume that you should just migrate to a microservice architecture. And I occasionally will have conversations where it's just assumed, well, we're modernizing our application and we must use microservices. No, I mean, certainly not if you're a small team with a small application. So you try and do everything to avoid using microservices, and then if and only if that is insufficient, right? You can't deliver your application sufficiently rapidly, frequently, and reliably, perhaps because it's incredibly large and complex and you've got a pretty large team of people, then it makes sense to adopt the microservice architecture. So then the question is, how do we get from our monolith to the microservice architecture? So this is a form of application modernization. And one best practice that's sort of evolved over the years is don't do a big bang rewrite. And that's where you decide, well, we're going to start from scratch and completely re-implement the system. That usually does not go well. And instead, what you want to adopt is an incremental approach. And the pattern that you use is known as the strangler application pattern or strangler fig pattern. Apparently, a few years ago, 10 years ago, Martin Fowler went for a walk in a rainforest and got inspired. And coincidentally, I was in Singapore a week ago, and I actually came across one of these strangler figs. So they're actually a plant or tree or vine that actually, this one in particular, starts growing in the canopy of a tree and then basically grows all the way down towards the ground, then starts growing roots, and then eventually it basically strangles the tree. Sort of essentially blocks out the light, and the actual tree dies, leaving this sort of tree-shaped vine structure in place. And so that's the metaphor. Your existing monolith is the tree, and this vine that's kind of growing up around the tree is this new application that you're building. using modern architecture, using modern technologies, which in this context would consist of a set of services. So that's the pattern, and it's based on this strangler fig metaphor. So you end up with a sort of your system looking like this, where over time, your monolith is gradually shrinking, and more of its functionality is getting migrated into the set of services, which are gradually growing in number over time. And perhaps at some point you just stop and you've said, well, we've achieved our goals of accelerating software delivery, even though we've still got the monolith, or perhaps you keep going until you've completely eliminated the monolith. And the general sort of technique here is basically intercepting calls to the monolith, which are being implemented by some module inside that monolith, and then redirecting them to a re-implementation of that module as a standalone service. And you're just sort of doing this one module at a time until you've migrated the necessary functionality out into the services. And every time you move functionality out into the services, you're sort of moving its development from the slow monolithic lane into the high-speed, DevOps-y, continuous delivery, continuous deployment lane that you're using for your services. So little by little, the pace of software delivery increases. So that's the general approach. It turns out an extremely good starting point for adopting microservices is actually to implement new functionality or significant chunks of new functionality as standalone services. Among other things, that tends to be a lot easier than tearing apart the monolith and quicker, which enables you to much more quickly demonstrate the value of microservices to the business. So you can go, hey, look at this shiny new feature we've implemented. See how much faster we can develop it and iterate on it. And with that, it convinces the business to kind of support the migration effort. So it's sort of like I kind of call this the stop digging approach. Because the alternative, right, would be to actually implement new functionality inside the monolith, which just makes the monolith bigger, right? You're just digging your hole deeper and deeper and deeper. So the idea is not to do that. So you end up with sort of, first time you try this, you end up with an architecture that looks like this, where you've got your existing monolith, right? And then you have this service that's implementing this new functionality, and it's this beautiful, pristine new service developed using DevOps and modern technology stack, with an API gateway sitting in front that's routing requests appropriately. Now, in practice, it's not that straightforward because often the service needs access to data that actually resides in the monolith. So you need some integration logic, which is code in the monolith and or the service that enables the service to access the monolith's database. Sometimes that's as simple as a REST API or some other kind of API. And that would just enable the service to either update or retrieve the data that lives in the monolith's database. So that's one strategy. The other strategy, which works well for reads, is for the service to have a replica or partial replica of the data that resides in the monolith. So it's got its own copy. And there's a few different ways of keeping that copy in sync. One way is to modify the monolith to just publish domain events or change events. When the monolith updates a business object, it just publishes an event to say that it's done that, like order created, order canceled, order revised, etc. The other option is to do it at the database level. You could just use some database-specific replication mechanism, like triggers. I mean, that's, if you like programming in stored procedures and the like, that works. There's more interesting techniques like change data capture, where you actually read the database transaction log and publish those changes as events. That's a slightly more advanced technique, but that can actually work well. So there's various ways of doing this data integration, and they sort of have different trade-offs. Like API calls are super simple, but at the same time, if you want to do complex queries against the data that you're retrieving, that doesn't work too well when you're doing it through an API call. It's much better to implement queries against a local copy of the data. The drawback of that is you've got the cost of replication and so on. And then in terms of doing the replication, each of the different options has various trade-offs, right? Like having the monolith publish events it means modifying the code. And given that your monolith is difficult to modify, those kinds of modifications might be tricky. In which case, it can be better to do it at the database level, but each of those options sort of has different trade-offs as well in terms of sort of transaction or kind of whether they're ACID consistent or eventually consistent and so on. The benefit of doing it at the database level is you don't have to modify the monolith. But it might just be as simple as writing triggers, right? If it's kind of a bit ugly to write database triggers, but that's one strategy for keeping databases in sync. Or maybe you could use something like Oracle Golden Gate, right? You spend a lot of money doing it that way. That's another option. But word out to our sponsors, Oracle Golden Gate is a good product. Anyway, so as you can read this, there are various different options with different trade-offs. So here's an example. So the example application in my book, which chapter 13 covers refactoring, shameless plug. The example there was it's a food delivery service like Uber Eats or DoorDash or Caviar or anything like that. So you can imagine the business they've implemented, the first version of their courier scheduling algorithm, and it behaves very badly, right? And so as a workaround until the new algorithm is implemented, you want to be proactive about delayed orders and contact the customer, inform customer support so that they can proactively follow up with the customer. So running some simple queries about the state of the world and detecting delayed orders. So rather than adding that into the monolith, you could argue, well, it makes sense to actually do this as a separate service, hence this delayed delivery service, which then integrates which detects that an order won't be delivered on time and then notifies the consumer with an apology and creates some entry in the CRM system. So, great example of a standalone service. Now, in order for it to work, it needs to know about the orders, the restaurants that those orders came from, because it needs to know where the restaurant's address and delivery and opening hours, and it also needs to know about couriers, right? Because figuring out whether an order would be delayed is a combination of those different factors. And so it makes sense to replicate that data into the delayed delivery service, but for the consumer, it needs the contact information if and only if it needs to contact the consumer. So in this example, that could just be queried through an API. So you need to do that kind of analysis to figure out what's the most appropriate way of accessing the needed data. So anyway, that's an example of implementing a new feature as a standalone service. And that's, as I said, is often easier, and it's a good way of demonstrating to the business that using microservices is a worthwhile investment. But ultimately, what you have to do, as I'm sure many of you are in the process of doing, you actually have to break apart the monolith. And what that entails is identifying modules that live inside in the monolith, along with that module's data, which can be entire tables or actually just subsets of columns of tables, and to define a chunk of functionality and the associated data, and turn that into a service. And that actually consists of a few different steps. Among other things, you basically have to hack the code to cleanly separate that module from the monolith. And this is a really horrible thing, especially if the monolith will need to call into the service. You have to identify all of the kind of access points and route them through a remotable API, which is quite unpleasant. You end up with sort of having to do something like this, modify all of the places and route them through this API. And you certainly have to do that for writes, because what will become a service has to own its data, which means it is the one that is updating its data. And ideally, you can do that, you should do it for reads as well. But one sort of shortcut that you can use for reads is actually to leave the data in place and then replicate it back. So later on, I'm going to talk about extracting delivery management out of the order management, out of the monolith. And there are certain columns of the orders table that are specific to delivery management, which ultimately will become their own table, the delivery table. And those columns will no longer exist in the order table, which sounds great, except there might be a whole bunch of places inside the monolith that are trying to read those columns. And one way of minimizing the impact of the change is to replicate those columns back. So the code that's reading them is reading this from this read-only replica and does not need to be modified. And later on, you can edit more, change more of the code, but this lets you do it in a more incremental way. And then once you've done that, you can turn that module into a service with the necessary data integration glue. And that new service might be a total rewrite of that module. It just uses the existing schema, implements the necessary API, or you could just use the code as is, clean it up, package it up as a standalone service. And then, of course, you need to have this data integration logic as well, except in this scenario, it could actually be going both ways. The service is accessing data in the monolith, but the monolith is invoking operations on the service to manipulate its data. So it's this two-way thing. So that's the basic process, and you repeat it until either you have completely eliminated the monolith, or you just sort of have better things to do, right? Or I should also say you've actually accelerated software delivery enough that it's okay to focus on features again. So kind of the key point is you don't necessarily have to turn the entirety of your monolith into services. It's only, essentially, in a way, it's just the parts of the monolith that you're actively developing are the parts that actually need to be turned into services. So it might be okay that you just have your monolith and you just have a handful of services that can enable you to achieve your software delivery metrics. And I should say, I mean, I don't have a slide on this, but there's a number of metrics that are useful in terms of like measuring success, right? Like sort of bad metrics are counting the number of microservices. And I've seen that at companies, and it's that's the worst kind of metric. A better metric is to actually measure the sort of the velocity of your software delivery. And there's two key metrics from DevOps that are really relevant. So one is is the lead time, which is the time from a developer committing a change to that change going into production. And sort of the modern thinking there is that should be under an hour, right? Versus if you have a monthly release, it will be a month, right? So one of the metrics that you want to optimize is reduce the lead time to get as short as possible. And then the other metric, which is somewhat related to that, is deployment frequency. How often are you pushing changes into production, which today is considered to essentially be once per day per developer. So over time, as you're migrating to the microservice architecture, you should see improvements in those metrics. And if you're not, you're doing something wrong, right? Because that's really the essence of the problem. I mean, there are some other sort of software quality attributes you can improve, like maybe some scalability. You might have scalability issues that can benefit and so on. But primarily, it's all about measuring velocity and improving it. So having said that, the other issue is, well, what to extract? You've got a massive system. Which parts of it should you turn into microservices? And I think a good approach is actually to have a limited sort of time-boxed architectural definition effort where you spend some number of weeks defining what your ideal microservice architecture should be. So that's sort of the target to-be architecture that you're going to aim towards, although you might adjust it as you learn more. And so that's, you know where you want to end up, roughly. And then you essentially want to take an inventory of all of the modules inside your monolith and sort of rank them by return on investment, right? You're going to for each module that you turn into a service, you're going to invest some amount of time, potentially a lot of time. So you want to be sure that you actually get the biggest bang for the buck, so to speak, right? So, you know, so it has to solve a key problem. So one benefit, of course, is accelerating software delivery. So if there's a particular module that's constantly under development, turning it into a service will accelerate the delivery of that, the development of that module. Or maybe if you've got some scalability problems or some reliability problems, those can be solved by extracting out the problematic modules into services. So you kind of want to focus your efforts on modules that will give you the biggest benefit. And then so you're sort of working your way down the list. And at some point, you might just decide, well, hey, we've got better things to do. Work on features and so on. So that's the general approach for doing this extraction. I want to now talk about an example. As I mentioned earlier, you know, the idea here is that with the food-to-go application, right, you know, a key part of the application is scheduling the couriers that are picking up orders from restaurants and delivering them to consumers. And you could sort of say that's the secret sauce of these kind of like, quote, real-time logistics companies, as they sometimes describe themselves, right? And so you could imagine that the ability to rapidly iterate on that part of the application is really critical to the success of the business. And I would say that if you could, there's a page, microservices.io/refactoring. It's a work in progress page, but I'm adding a whole bunch of content to that page over time. So current, you know, as is architecture looks like this, where the order management code and the delivery management code are just all intertwined with one another. In fact, in the actual example code, they're just basically in the same service class and in the same entity classes. And they both use the order entity, which is then mapped to a database table that has columns related to order management as well as columns related to delivery management. And then if you drill down into the actual code, there are some classes that are specific to delivery management. So like this notion, you have a courier that has a plan, and a plan is a list of actions like pick up here, drop off here, right? But some of the functionality is just intertwined with the order management code. So for instance, there are fields of the order class that are for order management and other ones that are for delivery management. The restaurant has an address. Well, the delivery management code needs to know the address of the restaurant, for instance. So it's all kind of tangled together. And obviously, the ultimate goal is to really separate it out. So, so all of the delivery management functionality is now in the delivery service. And then you could imagine there would be a new entity like delivery. But how do one issue is, well, how do you synchronize that with orders, right? If the order is canceled, the delivery needs to be canceled, and so on. And then the courier class is kind of an interesting one because the delivery management functionality is sort of managing the availability and the location of the courier, but then other parts of the courier, like their address and their name, actually reside back in the monolith. It's nothing really specific to delivery management. And then the delivery, which is picking up from a restaurant, is referencing some entity in some other service. So there's a whole bunch of really interesting kind of challenges around essentially database level, though it also represents itself at the domain model level as well. So the solution actually consists of two parts. So one part is the delivery service needs to expose an API that lets order management schedule, reschedule, and cancel deliveries. And then the other part is that the delivery service should have replicas of the restaurant and courier information. I should say partial replicas. It turns out it's just a subset of their columns or fields. And so there's this data integration glue that's needed to implement that. So that's kind of where it needs to end up. The actual process of doing this refactoring consists of 5 steps. Step number 1 is to split the code, like in place inside the monolith. Step number 2 is to split the database, define an entirely separate schema for delivery management. But this is still inside the monolith. We haven't actually defined any services yet. Step number 3 is to define the service and deploy it, and you could test it, but it's not actually used. Step number 4 is to actually use the service, so redirect any traffic or anything to do with delivery management into the delivery service. And then step number 5 is actually to remove the old code from the monolith. So it's sort of a series of kind of these incremental refactorings of the code base. And after each step, you are actually deploying the changes into production. So it's kind of like you're sort of driving down the freeway at 70 miles an hour while working on the engine. But it's safe, right? Okay, so step number 1 is to separate the code. So before, order and delivery management was intertwined in the same classes and so on. So now the goal is to actually define, kind of clearly separate the code. And in fact, delivery management is now, like in a multi-module Maven or Gradle project, its own module. And there's this interface that's connecting them. And like the delivery management has its own delivery entity, and as well as other entities. What's interesting, though, is they're mapped. It's still mapped to the order table. So in both orders and deliveries are both mapped to the same underlying order table. Separating the tables comes next. So kind of looks like this, right? Where you've got the order management module, the original one, and then this delivery management is this new module inside like your Maven and Gradle project. So there's like, this is a Spring application, so there's a new controller class that provides the external API, which is actually for kind of updating courier information. There's also this delivery service interface that's implementing the integration API that's invoked by the order service. And then say, like as I mentioned, the delivery entity is mapped to the order table. And then the other entities that are now introduced into delivery management, like restaurant and courier, are actually also mapped to the original tables as well. So it's kind of a little weird and sometimes tricky where you've got multiple entities mapped to the same underlying database table. But this is a good incremental step. And then step 2 is to refactor the database. Among other things, it's actually to extract out of the order table the delivery table. So we've got this now beautiful delivery table. And there's a great book called Refactoring Databases that describes the techniques that you can use to do this. And one of the shortcut ideas it actually had was to leave the original columns in place and replicate back to minimize so that you don't have to change all of the places that read those columns in one go. You can do that a little later. So, in terms of what the SQL would look like here's, to bootstrap this, you create the delivery table by doing a select from orders of certain columns where the order has an assigned courier. And then to actually do the replication or synchronization back, you can create database triggers. It's kind of ugly, but it's sort of, you kind of have to do whatever works, right? So whenever the assigned courier column is updated in the delivery table, it actually updates the assigned courier column in the orders table to keep it synchronized. And the similar thing is something similar is done with the other tables. So like with couriers, some columns are replicated from the monolith, other columns are replicated from the delivery service. Restaurants are just replicated one way because the delivery service doesn't own the restaurant any aspect of the restaurants. It just needs to know the name and the address of the restaurant. Once again, it's like you can just define triggers to do this. So I'm doing this at the database level simply because it's a good way of bootstrapping this without having to modify the monolithic code. Ideally, you would want the monolith to publish application events, but that requires more extensive code changes. So that's great. So at this point, there's a separate delivery management module that has its entirely self-contained schema with some synchronization implemented using triggers. And then the next step is to define the delivery service, which, as I mentioned, might mean reusing the old code or could also mean rewriting it from scratch. And at this point, you could deploy this service. No one is actually using it, but you can actually deploy it into your production environment, test it, and make sure that everything's working. And then once it is, the next step is to redirect all of the clients of delivery management to use the new service. So HTTP requests that are coming from the courier to update their availability or their location are actually getting routed to the delivery service. And then when order management wants to schedule, reschedule, or cancel deliveries, it actually invokes the delivery service. So the code that's here is actually unused at this point. And then the actual communication between them is done using asynchronous messaging. So this is actually a message channel. Think Kafka, Topic, JMSQ, whatever your favorite message broker provides. So the delivery service is sending command messages to the monolith is sending command messages to the delivery service, telling it to schedule, reschedule, or cancel deliveries. So, and then the final step, which is step 5, because now everything is working, is you can actually delete the old code. There's a few little nuances with this other mechanism. You might want to preserve the ability to switch back. So it's like, the service is not working as expected. Let's switch back to using the monolithic version of the code. And you might use feature flags for controlling that. And I talk about that a little bit more in my book. So that's one iteration of extracting out a service. And you basically just repeat this over and over again. And after many months, or in some cases many years, all of the useful functionality of your application has been migrated out into a set of services. So that's my talk, pretty much. So in summary, right, I mean, the primary goal of the microservice architecture is to accelerate software delivery. And so you want to measure success of this migration effort by looking at improvements in your metrics, such as lead time and deployment frequency. And you only really want to adopt this architecture when you've actually outgrown your monolithic architecture, right? If the reason software delivery is slow is because you have a highly manual development process, or testing and deployment process, adopting microservices will not fix that. You will have microservices plus a manual testing and deployment process, which will actually most likely be worse than having a monolith. And if you go to microservices.io, I've actually got a bunch of anti-patterns that talk about those kinds of things. So yeah, so it's like, so if you genuinely have outgrown your architecture, your monolith, that's when you want to start adopting microservices. A good place to start is implementing new features as standalone services. But ultimately, what you want to do is extract modules, basically carve up the monolith and turn chunks of functionality into services. And you want to focus on those parts of the application where you will get the greatest benefit. Modules that are constantly being worked on, or modules that are giving you scalability or reliability problems. And you might just do that with part of your application and then stop. You might at that point have increased the development velocity sufficiently that at that point in time, there's no further benefit to migrating any more of your application to microservices. Anyway, so that's my talk. Thank you for listening, and I hope that you will find it useful. And there might be like 1 minute for questions. Otherwise, just come find me 1 minute from now. Yeah, so the question is, what about transaction management? That's an excellent question, and the answer to that is actually there's some kind of subtle complexities around that, because one of the issues you can run into is you might need some form of distributed transaction that spans the monolith and the service. And for that, you need to use the saga pattern, which I think I might have spoken about last year here. So the key is sagas, but if you read chapter 13 of my book, it does talk about the interplay between the monolith and sagas and the problems that you can run into. In particular, sagas require you to implement compensating transactions, and modifying the monolith to support compensating transactions can be a little tricky. So that can impact the order in which you extract services. Yeah.
How long is the discount active?
Oh, I think a couple of months.
Okay.
I like to say today only, but
That's what I was thinking.
yeah, no, and actually I think it's for all Manning products.
Huh?
But go via my website, because I get a referral code. Or referral bonus, or I mean. All right, great, thank you.